Hi, everyone. We've just opened up, so I'm going to give it a minute here, but welcome. You're in the right place.
Welcome, everyone.
Okay. See lots of people in the room here. Thanks so much. Hello and welcome to this Hamilton Harbour Deep Dive webinar. This is a series that invites experts to speak to us on topics related to the restoration of Hamilton Harbour. Beyond this session, you can continue to learn more about the Hamilton Harbour Remedial Action Plan through our social media and website. We invite you to join our mailing list to be directly informed of future webinars and other engagement events. I'll be popping a bunch of links in the chat throughout today's session. My name is Carolyn Zanketta. I'm the Program Engagement Specialist with Conservation Halton. Conservation Halton provides the local coordination for the Hamilton Harbour Remedial Action Plan. We recognize and respectfully acknowledge that the land that we speak about today is the treaty lands and territory of the Mississaugas of the Credit First Nation and territory of the Haudenosaunee and Neutral Nation. This territory is covered under the Between the Lakes Treaty Number 3 of 1792. Together, we practice wise stewardship on the land and water in which we all share. So I'm looking forward to today's webinar. We will kick things off shortly with a few polls just to get some feedback from the audience here, and then I will do a quick overview of the Hamilton Harbour Remedial Action Plan just to get us all on the same page. Then we have Dr. Jim Quinn from McMaster University, who's going to speak to us about colonial waterbirds in Hamilton Harbour. We have Mike Christie here from the City of Hamilton, who will be facilitating our question and answer period after Jim's talk. And then after that, we have Shane Solla from Environment and Climate Change Canada, who will speak to us about herring gull, eggs, and chemical contaminants in Hamilton Harbour. And then we'll have another Q&A session after that before we wrap things up. So before we get to all that, I'm going to launch a couple polls. If I can find them here, one second. Okay, so the first poll is this your first time attending a Hamilton Harbour Deep Dive webinar? So this is now our fifth in this series. We started this a couple of years ago, and all of the recordings are available online. I will be sharing those in the chat as well. So if you've been here before, welcome back. Welcome to all our new participants. Glad you found us. I'll just let this poll run for a second here so we get some answers trickling in. Okay, looks like it's gone static there, so I'll share the results. We had about 62% say yes, this is their first time attending a deep dive webinar, so welcome. And 38% said no, you've been here before. Welcome back. Our next poll, how familiar are you with the Hamilton Harbour Remedial Action Plan? Very familiar, somewhat familiar, not at all familiar. Answers flooding in. Thank you. And of course, if you are not at all familiar, we will be having that quick overview just to get us all on the same page. Give that just another second here. Okay, we'll share those results. So 24% said they're very familiar, 53 somewhat familiar, and 24% not at all familiar. So let's bump that up to somewhat today. One more before we get started. How familiar are you with waterbird populations in Hamilton Harbour? Very, somewhat, or not at all. And of course, that is the theme of today's presentation. So hopefully by the end, you'll have a different answer. Okay, those came in pretty quick. Thanks, everyone. We had 18% say very familiar, 70% say somewhat familiar, and 13% not at all familiar. Perfect. Thank you all for participating. Kind of keeps it fun for us too. We'll have two more polls at the end as well. So just a bit of housekeeping here. We have a Q&A function at the bottom of your screen. Please use that to type in your questions. If you don't see it right at the bottom, it might be hidden beneath the three dots of more. Just take a look there and hopefully you'll find it. We'll have some time after each of the guest presentations to try to address your questions either live or in text as we go along if it's something that we can just fire off quickly. We hope that there's lots of great questions and insight. Please don't be shy. We'll address those related to the presentation topic first, and others if we have time. If we don't get to your question, just please note that we will be considering all the questions and feedback to help inform future topics for the webinar series. Today's session is being recorded, and it will be posted on our website within about a week. So I'm going to kick us off with a quick overview of the Remedial Action Plan. As we know, many of you are already familiar, but just to get us up to speed, let's do a high-level overview. So the International Joint Commission is a group that deals with the boundary water issues between Canada and the United States. In the 1980s, the Commission designated 43 sites around the Great Lakes as areas of concern. These were sites where water quality and ecosystem health have been severely degraded by local human activities. Each of these areas of concern has its own Remedial Action Plan, or RAP, which is locally developed, partnership-driven, that guides restoration efforts. So the goal of the RAP is to address historical environmental issues and ultimately remove the area from the list of areas of concern, which is a process called delisting. There are a number of watersheds that drain into Hamilton Harbour. These originate in Hamilton, Burlington, and Puslinch. Watershed is just an area of land where all of the water drains down into one place, kind of like a bathtub. The rain that falls into the upper reaches of these watersheds makes its way down into Hamilton Harbour, picking up nutrients and pollutants along the way, like road salt and oil or fertilizer and manure. We all live in a watershed, and what happens upstream is impacting what's happening downstream. So when we talk about the Remedial Action Plan, we define the degraded water quality and ecosystem health by beneficial use impairments. A beneficial use impairment, or a BUI, describes the human or ecological use of the ecosystem that has been degraded because of human-caused environmental problems. There's a list of 14 potential BUIs for every area of concern, and this provides us all with a common language for how we can talk about impairment and remediation. Hamilton Harbour's historic environmental conditions led to 11 of the 14 BUIs being applied here. So for each of these BUIs, we have environmental goals called delisting criteria. These were developed to describe the environmental conditions that will be achieved once all of the actions have been completed. The delisting criteria are used to guide the restoration efforts, and progress is measured against them. So once all these actions have been completed and the delisting criteria have been met, a BUI status change is proposed in a redesignation report. The BUIs and their actions are often interconnected, and today we're going to learn a bit more about BUI 3B, which is the degradation of wildlife populations, among others. The Bay Area Implementation Team is the group of partners that work together to develop and coordinate remedial actions for Hamilton Harbour. These partnerships drive and guide the plan to support the environmental changes needed to remove the remaining BUIs, with the ultimate goal of delisting Hamilton Harbour from the list of areas of concern. So these are just a few of the remedial actions that partners have been working on over the years that you might recognize. Our speakers tonight will touch on some of this, including information about the Bird Islands and Windermere Basin. You may have joined us for our past deep dive webinars. We did one all about the Rendell Reef Sediment Remediation Project and another one about the Woodward Wastewater Treatment Plant upgrades. And if you haven't seen these recordings are available online on our website. And again, I'll link those shortly. So perhaps you're also familiar with the fishway between Cootes Paradise and Hamilton Harbour, which was created to help manage carp populations in the marsh. It's open again for visitors for the season, so take a walk down from Princess Point to check it out. I'll put that schedule in the chat too. Maybe you enjoy exploring Windermere Basin, or maybe you're here today because you're curious about the waterbird colonies on the islands near the Skyway Bridge. Both of these sites help to improve habitat and support fish and wildlife populations. So there's been a ton of great remedial action taken over the years to improve water quality and habitat in Hamilton Harbour, and there's still work to do to meet all of our delisting criteria goals. So if you're feeling inspired and would like to learn more, or maybe dive into the details, please go ahead and visit our website for all information on all of these beneficial use impairments, as well as some of the key reports, and you can track our progress there. We recently published our 2025 annual report, which I'll link to in a minute. Follow us on social media at info@HHRAP, and sign up for our mailing list as well, and join us for more events like this in the future. Okay, we're going to get into it now. I'm really excited to introduce our first speaker. This topic is one of my favorites, and it's actually how I got my own start in this field, so it's pretty near and dear to my heart. So I was actually one of the field assistants who worked on this project as a student 15 years ago, and it's here that I fell in love with Hamilton Harbour and birds. And after that, I knew that I wanted to be involved in some way, shape, or form with the Hamilton Harbour Remedial Action Plan. So I'm pretty lucky that I am. So I'm very pleased to welcome Dr. Jim Quinn. Jim is an emeritus professor in the biology department at McMaster University. He studies the behavior of birds living in complex social groups and the effect of air pollution on DNA in birds and mice. He has headed up the Hamilton Harbour Colonial Waterbird Management and Monitoring since 2007. On campus, he is co-chair of MAC Green Invest, a faculty-driven group seeking to have McMaster divest from fossil fuel companies and reinvest in green energy companies. Jim is currently a member of the Hamilton 350 Committee, an organization dedicated to mitigating human-caused climate change, and also a director on Environment Hamilton's board. So please take it away, Jim.
Thank you. Thank you, Carolyn. Hopefully I can share my screen and
I'll stop to make it easier.
sharing my screen. I'm not sure if I've got the when I was trying to get it on, I was not getting the audio. So I may stop sharing very briefly and then
Sure. Let's try again.
reshare again. That's not allowing me that. Interesting. It's not giving me that option. I'm clicking on it, but I get nothing. Well, that's unfortunate.
That's strange. Sorry about that, Jim.
Yeah, I don't quite know why that is. Okay, well, I will.
You're looking good, Jim.
Okay, so you can see. Okay, that's great.
Good job.
Okay, well, I'm going to begin really talking about a couple of projects that are not really central to the monitoring and management of the harbor. Just to give you a little bit of background on how the early research that I did in the harbor before getting going with the monitoring and managing. And the first project was based on this grocery store barcode, which is a DNA fingerprint. It's of 3 families of herring gulls. And I don't know if you can see my cursor, but you'll see some arrows here. And these arrows are pointing at bands. These are pieces of DNA that are size fractionated. And they're from nestlings in families where there's no matching band in mom or dad. And now, unlike robins and many other birds, herring gulls are incredibly faithful. So these bands are not due to any fooling around or anything like that. These are actual mutations, probably in the sperm. Now, this project revealed that multi-locus DNA fingerprinting mutations are elevated in steel mills, both in Hamilton Harbour, which is where we started with this, and also in other steel mills, including LTV Steel, Algoma Steel, and steel mills in Detroit. Basically, we have some concerns. We had concerns. Herring gulls were showing us the way that there were elevated rates of mutations in the DNA. And this is the person who did the bulk of the work. This is Dr. Carol Yock, one of my students back in the day who was very successful. She went on to be a scientist in the mutagenesis section of Health Canada, and then ultimately to become a professor at Ottawa University, where she is a professor now. And she's been extremely prolific, done very well over her career so far. Once we had established that, we decided that that we should look at another way using mice, because with mice we can control where they're going to feed, what they're eating, what they're breathing, and so on. And so I'm going to mention this one paper. We published a number of papers, but this one represents a study where we took these mice, we housed them inside these garden sheds that had a screened opening so that air could blow into them. And mice were kept in here, separated out by sex for 10 weeks. And they were positioned right across the harbor from the steel mills or on a llama farm in Freelton, Ontario. And what we found was that those that were housed inside this garden shed were more prone to mutations. We could identify that these were paternal mutations for sure. They came from a different type of mutation that's a single locus marker. So because it's single locus, we were able to determine that it's the male band, that this came from the male band because the female band is already here. So we could identify which parent the mutation came from. And we followed up this experiment that showed there was an increased rate of mutations with another experiment that's shown here. And in this experiment, we have the rural exposed mice. This axis is per band mutation rate. So this is the rate of mutations. And then we've got a number of treatments here. Rural means you're up in the llama farm. Urban industrial, which is where we have this high level of paternal mutations, is across from the steel mills. And then this next one, urban industrial HEPA, we filtered the air going into the garden sheds with HEPA filtration units. And because of that, the rate of mutations dropped right down, indicating that the mutations are caused by particulate, breathable particulate that's removable by the HEPA filters. So this was some, I think, quite important work. It was very early work in trying to determine mutation rates in the field. And Chris Summers, my student who's shown here, he wanted to get in on the action with the colonial nesters as well. So he's shown with a Caspian tern here. And some of you will recognize Dr. McCary here. Dr. McCary was a big part of this particular paper that we were doing, as we were trying to get a better idea of what chemicals were coming through the filters or were being blocked by the filters. So these two students have contributed a lot to the beginning parts of the work that I was doing in the harbor. Now, on to the management and monitoring. There are two main areas that I'm going to be speaking about. One is Hamilton Harbour north of CCIW along Eastport Drive or along the Skyway and the Queen Elizabeth Way Bridge. And the other is Windermere Basin, which is near the outflow of the Red Hill Creek. So here's the Red Hill Creek coming along, and it empties into Hamilton Harbour over here. And I'll talk more about that momentarily. I'm going to be developing a series of problems, and some of these problems cause other problems. And it's when you're dealing with this many species and this complex an environment, you are dealing with lots of problems, and they do intersect, and they are quite complicated. But I've laid it out in a more linear pattern. So problem one was that the Hamilton Port Authority, now called the Hamilton Oshawa Port Authority, planned to develop some of Pier 26 and 27. So this area of land was going to be lost. At the time, it was covered by colonial nesting birds. There were over 40,000 pairs of birds nesting on this land at the time. We knew it was going to be lost. So we decided we should do something about it. And the decision was to build 3 islands north of CCIW. These are the islands. We published this paper, Design and Management of Bird Nesting Habitat, Tactics for Conserving Colonial Waterbird Biodiversity on Artificial Islands in Hamilton Harbour, Ontario. And we made a statement in this paper that I think rings very true. We propose long-term management procedures based on aspects of the biology and known ecological interactions among the various species of colonial nesting birds. And it turned out that this is a very long-term management effort. I was hoping we could get these islands in place, sort everything out, and everyone would stay in their places. It's not the case. So how do you go about this? Well, you build a road out into the harbor, and you build that road to 3 different axes, points. And once you've built up the 3 islands, then you just dig the road back out. And in this picture, you can see 2 of the islands. This closest one is called Center Island, and it's nearest to CCIW. And then there's, sorry, this is South Island. Then there's Center Island, the middle one, and North Island is off to the upper left. It didn't make it on this picture. So we built these islands, and we had topped them with substrates and planted them in ways that would attract these various species to these locations, or so we hoped. In reality, it didn't really match very well. Although Caspian terns, they were targeted for here, and that's where they ended up right away. So some of it worked out, but we ultimately, after a few years, had all of the 6 species nesting on those islands. We also had ideas of what we needed to do in terms of habitat features and also short-term management plans. And I'm not going to go into any depth on that. You'll encounter some of what we had to do as I go through this talk. And I only have half an hour. It's tough to get through it all. I show this picture mainly because most people, when they think about double-crested cormorants, which many of you will know, they don't think of this bird. This is a double-crested cormorant in breeding plumage. It has 2 crests. That's why it's called a double-crested cormorant. But most of you will recognize it as this bird. No crests at all. It's just bald. This is not in breeding condition. In any event, I'm going to introduce the players in the harbor. This is the double-crested cormorant. The ring-billed gull. The ring-billed gull is the smaller gull of the 2 that we have commonly around here. It has a black ring around its bill. It has bright yellow legs, and it's about half the size of a herring gull, and it's very, very numerous, as are the cormorants. These 2 are considered conservation nuisances. They get along fine in areas where there is lots of disturbance, human disturbance, and they crowd out other species, and the cormorants deliberately take nesting material from other species, including this species, black-crowned night herons. We don't have a good handle on black-crowned night herons. They bounce around a lot. They have very, very little site tenacity, and we have to look hard for them. They seem to move frequently between seasons. The herring gull has pink legs, unlike the ringbill. It has an orange spot on its lower beak, and it's about twice the size of a ring-billed gull. And they're way fewer in numbers, and we're concerned about them, and we're trying to make sure they have nesting habitat in the harbor. They are declining generally in the Great Lakes. This is the Caspian tern. Caspian terns are the largest terns in the world. They have a very disparate distribution pattern. They're found in a disjunct pattern where they are numerous in certain places, but they're spaced out pretty far apart. We're trying to keep hold of our Caspian terns in good numbers, although I must say I'm not going to get into it today, but last year we were hit hard by H1N5 influenza, and we lost 90% of the population of Caspian terns last year. I'm hoping they'll come back. We're going to be following up on them to see if they've acquired immunity. And finally, this is the common tern. Common terns are much smaller than Caspian terns. Caspian terns are big enough that they fly like a heavy-bodied gull. They just kind of fly along. Common terns are light-bodied. They fly like a marionette. They bounce as they flap. They sort of bounce up in the air. Common terns are declining in the lower Great Lakes, and they are a species of conservation concern, and we're trying to keep them in the harbor, building up in numbers. So let's see how we went about some of these challenges. First of all, you have to choose a substrate for the birds to nest on, and we did a study to try to figure out what would work well for Caspian tern nesting before the islands were built. And we published this in a journal called Biological Conservation. And what we did was we took 3 of the available substrates that could be purchased and had in large volumes, and we asked which of these 3 would Caspian terns like to nest on. And the way you do this is you basically set up, it's sort of like laying a patio, except you have graduate students and you pay them in beer and pizza instead of money. And they help you lay out this little area that looks kind of like a tic-tac-toe game. You'll notice that each of these three substrates is laid out once in each row and once in each column for a balanced design. And we don't really care where these people that helped out are hanging out. We don't even care where this English postdoc who did all the fancy touch-ups at the end is hanging out. We care about where the Caspian terns go. You'll notice that the Caspian terns preferred our substrates to the substrates they were used to nesting on, which are all around this Latin square design. And we found that we could tell that they did prefer certain substrates. And on in this table, what we see is n equals 5. That represents the number of pairs that nested in that particular cell. And in parentheses, the other 5 there is the number that nested last year, the year before this study. So we know how many nested in each of these areas. And there are some dramatic changes in some. Sand, n equals 17 versus 7. And what we found was that these birds preferred sand. And so this is showing the total number of clutches that were initiated on the experiment by date. And you can see that sand crept up pretty fast. We also know that just because there were so many that were nesting on sand, you might think, oh, they're at high density, maybe they won't do as well. But they did pretty much as well as the other two substrates in terms of their number of chicks that they fledged per pair. So it doesn't harm them to be at these high densities, and we figured that sand would be good. Now, once we did put sand out on the islands, and this is actually a picture of the experiment, but this carried on. We found that they really like to find little bits of stone. So they were going by in the cells nearby and stealing gravel and lining the nests with that gravel. Once the islands were built, we knew that ring-billed gulls would come before the terns. And so this is the north knoll of the North Island. We laid down this polyethylene because gulls don't like to nest on polyethylene. And now we'd love to replace this with something like giant jacks, the jacks that you spin and bounce balls and everything. I'm not sure what we can find, but I don't like the fact that we have to throw this out each year. But we're looking for alternatives. In any event, we put down the polyethylene and we save it for the terns. We had a little helping hand by foxes that migrated down the Red Hill Valley, down the Red Hill Creek, and ended up on Pier 26 and 27 and scared Caspian terns off the mainland and onto our island. And so before we even had pulled back the polyethylene, the Caspian terns had arrived. So it was a success. Problem 2, protecting trees for black-crowned night herons. Black-crowned night herons nest in trees that have leaves, and they nest in trees in similar locations to double-crested cormorants. Double-crested cormorants actually defecate on trees and kill them. This yellow circle defines South Island. This is where we wanted to protect the trees so that the night herons would have nesting habitat. And this is what the trees look like typically each spring, covered with cormorants. The cormorants come in, and there are there's a night heron here and another one back here. So there are a couple of night herons in there, but even if they are trying to nest in there, cormorants will steal their nesting material and take over their nests, not to mention the risk of killing the trees. So we had to push cormorant nests out of these trees 3 times a week for a great part of the summer. Now here are some of the years. You can see in early spring, there are already cormorants up there. Later on, well, this is pretty much same time of spring. And then we kept pushing these out. The same birds would come back and build the same nests in the same locations, and we would push them out. 3 times a week we were doing that. And ultimately, though, we were successful in keeping the trees alive. This could be last summer. I mean, we've managed to keep these trees alive since 2007 by just keeping the cormorants on guard and off their nests much of the time by pushing their nests away. That's in late June. And this figure shows that the number of double-crested cormorant nests removed from trees over from the 15th of May through 28th of June. Now, this is 3 different years. So generally it's from early May until mid-June or so. And these nests like these birds will be pushed out and then they'll come back and re-nest. So it's a lot of work to keep that clear, but we've managed to do it. Problem 3, water and cormorants taking over herring gull nests. Now, I'm not going to deal much with the water situation, but a couple of years in the past several have looked like this on Near Island, which is one of the main islands where herring gulls nest. They had nests there. The nests are now underwater. This is a problem that's being dealt with. Hopefully, in the near future, this island will be reconstructed and will be elevated above the level of high water. And so maintaining habitat for these gulls. But I'm not going to get into that today. The other problem, though, is cormorants. Here we see a herring gull egg, the darker egg, in a nest that was built by herring gulls with a cormorant egg in that nest. Now, what will typically happen with this nest is cormorants will come in and they'll convert that herring gull nest into a cormorant nest, and the herring gull will lose out. This is something that we looked at quite closely. Chris Summers was involved in this again. We looked at these interactions, and we were very concerned because there were, at one time, 2 islands in the harbor that were housing hydro towers to get electrical lines across the harbor. Far Island was one of those, and Far Island lost its entire herring gull colony to cormorants. This is Near Island, the remaining one. Far Island has subsequently been sunk for fish habitat, so it's out of the picture now. But in this picture, you can see these are all herring gull nests that have been converted into cormorant nests. So this was a big concern. Now, one of the things that I noticed was that herring gulls are much more brave than cormorants early in the year. These birds aren't flying off. The cormorants are all in the water. And that led to the first approach, which was having my field assistants sit on Near Island and read a novel or something. The problem with that is 4:30 or so, they get hungry and then they leave. And overnight, cormorants come back, rebuild their nests, lay their eggs again. So we had to bring in our secret weapon. This is our singing, dancing Santa Claus. And singing, dancing Santa did a good job because the cormorants were afraid of him and the herring gulls were not. So anyway, as you can see, herring gulls don't mind Santa, and they would nest right near Santa. And this had a pretty good effect in the sense that the number of nests that had to be removed from Near Island and North Island, just in order to save the habitat for the herring gulls, dropped precipitously when we had the field assistants reading, and then once we put Santa in place on Near Island, the nesting of the cormorants dropped to 0. North Island was a little trickier because it's a bigger island and we had to move Santa around a bit. And so we thought we had a great solution to this problem, although over time, this is 4 years later, and the cormorants have discovered that they don't believe in Santa anymore. So all of these around here are cormorant nests, active cormorant nests. They don't care that there's a Santa there anymore. So that didn't work anymore. Now, mind you, the knowledgeable birds don't come to these islands anymore, the ones where we were using Santas, because they know they're going to get kicked off the islands. And so it's been enough years that have gone by since we used Santa that we're aiming to do this again. So if any of you have a singing, dancing Santa that you hate, or some other animated figure that would draw attention and move around and scare cormorants, please get in touch with me, because we will probably buy it from you, hopefully at a slight discount, but we'll take it off your hands if it's getting on your nerves, and we're going to make use of it this summer, hopefully. Problem 4, securing safe nesting habitat for common terns. I've told you already, common terns are considered very important. This ignore these early counts. They were very early on, and they were visiting very few colonies. But there's a general tendency that we have been able to see of decline over the years in terms of numbers of common terns in the lower Great Lakes, numbers of common terns nesting in the lower Great Lakes. And this has been persistent. So we need to do something about it. We're trying to help them as much as we can. Here's a picture. The top picture shows Windermere Basin in 2009, and this is when it was just a settling pond. So here's Red Hill Creek coming in. The water slows down and it drops these contaminated sediments into the basin and then flows into Hamilton Harbour. Well, that mess was largely cleaned up and covered with a type of material that will not allow the toxins to come up, and it was shaped to allow for shoreline that shorebirds could forage on, and 3 islands were built in Windermere Basin specifically for common terns. This 4th island, Spurdyke Island, was already there. So the idea was, here are the 3 new islands in Windermere Basin, and this spot is where the common terns nested during the construction of these islands, because the colonial nesting birds had to be chased out of the area in order to allow the construction to occur. So here's where the common terns were, and we just needed to move them over to these islands. So here are the islands. They have a nice substrate of sand and pea gravel on the surface. The shoulders are cobble, essentially. And what you see here are 2 speakers and a solar panel that will power those speakers and the device that broadcasts them. On the islands, a predator company perched hawks to keep the gulls from coming and nesting on the islands. And we put out these decoys to attract common terns to the islands. So we used social attractants and gull deterrents. And we were successful. We brought the common terns right over. We had hundreds of pairs of terns, of common terns nesting on our islands at the very beginning. And here you can see a closer view of them. There were still some ring-billed gulls that would come and try to nest, but the contractors had permission to remove their nests. And so we were able to keep the islands largely islands used by common terns. However, we ran into another problem. One problem leads to another, excluding Caspian terns. Caspian terns, sometime later, a couple of years later, discovered these islands. And they thought, these are even better digs than the islands we're on in the harbor. So let's go over to Windermere Basin. And they basically took over the tops of the islands, the part that we wanted for the common terns. Once the Caspians got there, common terns had to just eke out the spots on the shoulders, which is problematic, as the chicks, if they're hiding from predators, they can go in a crevice. Hard for a chick to back out of a little hole between big rocks. So how do we get rid of these Caspian terns? Well, our first attempt was to use polyethylene, the same as we had used with the gulls. We thought maybe if we put it down, because Caspian terns come earlier, maybe they would avoid nesting on the polyethylene, and we could peel it back and there would be some habitat left for the common terns. However, that didn't work. This is a picture of that island. Half of it's covered with polyethylene, the other half is not. This is before plastic removal. They just laid on the polyethylene. So we tried another trick. Here's Dave Moore helping out with stringing these strings across the colony in hopes that Caspian terns being larger than common terns, the common terns would fly down between these strings and would nest underneath them. This is something that has worked to keep ring-billed gulls away from common tern colonies. Unfortunately, neither of these worked, so they both failed, these efforts, and we tried different distances apart of the cord and so on. Then in 2019, we started seeing signs of great horned owl predation, and great horned owl predation involves decapitation. So both chicks and adults were being decapitated. Now the next I've got a little video clip coming up. If some of you are squeamish, you might want to avert your eyes. But this is what what a great horned owl does to a chick, and this is why we find these decapitated chicks and adults. So that was a problem. The owl was killing and eating some of our chicks. However, what was more of a problem was, and if you watch over in the lower left, you're going to see a great horned owl come out to meet an adult common tern that's going to appear sort of in the middle of the frame. And this is even worse for the chicks because that adult is dead. Other adults see that. They know that there's this deadly predator there. They desert the island and they don't have good nocturnal vision. They don't come back all night because they're worried about being predated. And their chicks die because they can't yet thermoregulate. So there was failure, like very serious failure for both species for a couple of years. They over 1,000 pairs of birds produced. One year they produced 7 chicks that fledged, and they produced 1 chick that fledged. So very bad situation. Good news is that the Caspian terns eventually learned a lesson and they went back to the harbor. So we didn't have to worry about getting rid of the Caspians anymore. They were smart enough to say, we're getting out of town. So problem 6, protecting common terns from owls. Here's the solution that we came up with, the royal we. This was some researchers in New York and researchers at Presqu'île Provincial Park who had come up with this fence design where these fences come in little panels, but the top rail is the important part, where there's a hot wire, an electric fence wire, and running down the middle of the top rail, this rail, and 2 ground wires that are distant from it over the edges. Now, it turns out that you have to have large feet to connect the ground to the hot wire. Here's a common tern standing on a hot wire. Here's the ground. And so Caspian terns and common terns and ring-billed gulls and herring gulls have small enough feet that they don't make this connection. But great horned owls don't. So we set this up. We have a camera here to record what was going on. And what we found was that that there were coyotes in the area as well, but we also found that we got rid of the owls. So there's no sign of the owls, no decapitated adults or chicks, no owls on camera. Nocturnal desertion, however, continued because the coyotes could just jump over the fence. In 2022, only 10 common terns fledged. In 2024, Hamilton banned our use of electric fences outright. We tried using flashing lights to repel coyotes. That attempt failed. Coyotes predated the nests and caused the nocturnal desertions to keep on happening. Now here we see in 2024, without having any electric fences working, the fence is still up, but it's not electrified. We see both the coyotes, and now we're starting to see black-crowned night herons that are coming in and predating young tern chicks. So we've got another problem to deal with. Problem 7, protecting common terns from night herons and coyotes, was resolved thankfully because Hamilton allowed us to use electric fences. So here we see these are 2 electric fence lines that go around the circumference of the islands. They're hot. So if you hit either of them, you're going to get a shock. Meanwhile, up top is that fence to keep the birds, the large birds, from predating. This picture was taken on May 11th. And here you see a coyote both outside and inside the fenced area. This was the day before we turned on the electricity on the electric fence. Electric fences were fired up May 12th. No predators were detected thereafter. And we have the first evidence of successful fledging since 2019. These are the common chicks that were mature enough that we could pick them up and put them in these buckets on June 26th, 2025. These were enclosed inside the fence on Island 3, one of the 3 islands there. We had 62 chicks that fledged that year. The fledging success per nest was 0.86 to 1.41 fledges per nest, which is a respectable rate of fledging. So I think we're on the right track, and hopefully we can keep those electric fences going. And that's where we're going from here. And at some point, someone's going to let you ask questions, apparently. So I will stop talking now.
Thanks so much, Jim. That was fantastic. Real run through there of a lot of years of adaptive management. So thanks for giving us the highlight reel there. I'll pass it over to Mike for the Q&A session.
Yeah, sure. Thanks, Carolyn. And thanks, Jim. That was great. And as a non-bird expert, I learned a lot. So we have one question so far. And folks, if you'd like, you can use that Q&A function at the bottom of your screen. If you don't see the Q&A button along the bottom panel there, you can hit the More option, and you can select Q&A. Okay, Jim. First question, you may have a successful option for maybe future deterrence. Um, how would an animated predator work to replace Santa? We have a question from Gene. So if that would work, maybe you want to give your contact information to see if you can have a little exchange.
Absolutely, absolutely. I would love to. You can reach me. Anyone that has anything that's large and moves around and can be battery powered. My address is Quinn, Quinn, at McMaster.ca. McMaster spelled just like the university.ca. So my last name, Quinn, at McMaster.ca. I think a predator would be even better than a Santa potentially, as long as it's bigger than a coyote.
Right on. That's great. Um, so there's actually two questions that are the same. Why didn't Hamilton allow the electric fences? Unfortunately, Jim, I wasn't around for that time. I'm not sure if they gave you a good
Well,
reason.
fortunate for you, I guess, maybe. I would say it was probably litigious lawyers that didn't know enough about electric fences and thought that someone would get electrocuted on the electric fence. That's my only guess.
That would be
They
my assumption too, is because it's a city-owned property, there may be some liability concerns around the use of electric fences, and so yeah, that would be my
So I
guess.
think what happened was someone that knew about electric fences had some words with the people that said they were so dangerous they were risky, and that was straightened out.
Great.
I've been shocked by electric fences many times. Now that does maybe you're thinking, oh, I'm going to stay away from those.
Um, we have just a comment. Super interesting. Thank you, Santa Jim. So that's great. Uh, next one from Kim. Are there plans for more nesting sites to be built in the future?
Not in Hamilton Harbour, as far as I know. There are plans, as I mentioned, to bulk up near Island and also to some extent Center Island because of erosion and loss of materials. I must say, though, when I mentioned that we figured out how to construct these islands, we didn't do the engineering. If we biologists had engineered these islands, they would be long gone. I would claim. We topped them. We basically decided what vegetation would go where, whether we're going to put little hillocks on the edges, and whether we're going to have bays coming in. So that was what we did. I don't foresee this happening in the near future. Hopefully, it will. We certainly have way less habitat than we did when the birds had the run of Piers 26 and 27. But yeah, I don't know of any plans to build new islands or new habitats in Hamilton Harbour.
Okay, great. Next up from Deborah. Are the islands along the LaSalle Park shore hosting nesting birds?
They're very few. We go out there and count them every year. We keep track of all the nesting birds in the harbor, and usually we'll find a couple of pairs of herring gulls, often a swan or a goose. And sometimes in the past, there have been common terns on some of those smaller islands, but that hasn't happened. There haven't been any nesting common terns for a long, long time on those islands. So they're not big in the picture in Hamilton Harbour right now.
Thank you. Next up from Nancy. Nancy, thanks for joining us. Can you speak more about plans to raise the island that is submerged in your slide?
Yeah, that would be, I'd pass that on to the engineer if I had one here. Um, they, there are plans, they're going to be putting, like they use very large stone to secure these islands, and they're going to be putting more in. It's going to cause the island's top to be a little smaller. It's going to bring it up, and then there will be cobble and then a substrate on top of that cobble. The substrate of near island is not perfect for herring gulls by any means. So this will bulk it up. It will give more structure to it. It will shrink the surface though, because the rocks have to come in like this, and they're going to go up higher. So we'll have a little bit less space on top. But there have been 2 years when those birds just it's pretty pathetic looking through the water and seeing three beautiful herring gull eggs in a nest underwater. This beats that for sure.
Okay, thank you. Is the cormorant population stable or growing?
Cormorant population seems to be pretty stable. It has been growing in the past. Unfortunately, the powers that be decided that they thought it was a good idea to have a cull and to kill cormorants. And anyone that knows anything about how populations grow will know that there's a logistic growth curve. It's like an S shape, where there's a very rapid rate of increase at a certain level, and then it tails off as they reach a carrying capacity. My belief is that they've pretty much reached that carrying capacity, and that the Fish and Wildlife Service, Canadian Wildlife Service, and the US Fish and Wildlife Service, in certain areas where they're killing cormorants, what they're doing is they're bringing the numbers back down to this steep part of the growth curve. So they're creating more work for themselves. They're going to have to keep working because population is going to grow quickly because they've knocked it back to a certain level, and there's room for growth.
Okay.
So I would say it's close to carrying capacity. We've been right around 45,000 pairs in the harbor for a few years now. It bounces around a little bit, but it seems to be reasonably stable now.
Okay. So to build on that cormorant piece, Jim, a question from Pat. If there is an overabundance of cormorant nest eggs to be hatched on the island, is there any control in place?
The only control that we use is to protect real estate. So South Island, we do not let cormorants nest on South Island. We remove all the nests from the ground. We remove the nests from the trees. We maintain that island, hopefully in the future, for black-crowned night herons. I don't know how likely that's going to be, but we don't allow them to nest there. We allow them to nest on the center island. That's theirs. That's for them to take. And it's quite clear when you see them come in the spring that they know where they're supposed to go. The experienced birds go right to Center Island and they start nesting right away. The stragglers end up on the other islands, and they get removed. And they're being removed specifically to maintain trees, to maintain nesting habitat for night herons, to maintain safe spaces for night herons, because the night herons are still nesting, but more among the rocks. But the cormorants will steal their nesting material and take over their nests, as they do to the herring gulls. We're also getting rid of them on all the islands where the herring gulls are nesting, so that the herring gulls have nesting habitat. So we're not trying to control necessarily the numbers, but we're trying to control what areas in the harbor they occupy.
Okay, thank you. Nancy just had a follow-up on those submerged islands, Jim. She just was curious where that submerged island was located, whether it was always man-made or whether it's natural.
It's man-made. It is. If you were at the harbor and you saw where Near Island is, you could picture another island further along that would allow you to connect with hydro wires from the side you're on to the north shore, the northeast shore. That there were a number of biologists that were working away at trying to come up with a way to discourage cormorants from roosting and nesting on those islands. It was because of complaints of the neighbors that were on the North Shore that there was any reason to do anything. And after working away for quite a long time and coming up with some ideas of smaller islets that made it harder for cormorants to they'd have to fly up over a lip, and it would be energetically costly, and they'd have to fly back up to get back in, things like that. Port Authority and or city, but combination, they just said, "Ah, the hell with it. We're just gonna sink it." So they sank it and called it fish habitat.
Okay. Thank you. Uh, from Dan. Thanks, Dan, for joining us. Will research continue to develop solutions that require less human intervention?
Boy, I wish I could say they would. I wanted to walk away from this very soon after I started. Not that I didn't like what I was doing, but we had plans in mind, and we thought, okay, now you guys are going to be here, and you're going to be here, and you're going to behave nicely, and you're going to let each other have your space, and you're not going to interfere as you are. Unfortunately, as I mentioned, cormorants and ring-billed gulls are conservation nuisances. We could let it go. We could walk away right now, and we will have two species in the harbor. I don't like that. I think especially given the fact that there are common terns here and herring gulls are declining, I think we need to try to fight for them and give them a place to live because they'll lose it otherwise. Sadly,
Okay.
I mean, I'm with you on that wish. I wish we could just set it up and let them go, but not going to happen.
Okay, a couple more questions. You mentioned how poor fledgling rates were for the common terns relative to the number of nesting pairs. And Amanda was curious what kind of population sizes are there for each of these birds?
Population sizes are there globally? So they're
Um,
not
s-
glo
yeah, go ahead, Jim.
they're not. Go ahead. Go ahead, Mike.
No, I think maybe we'll start with more local, and then if you
Okay.
do have comments broadly, then great.
Yeah, locally, the numbers have been as high as 1,000 pairs of common terns. They have dropped gradually. They went down to 600, and now they're down around 250, 150. So they've dropped gradually over time due to predation and competition for space. I think at this stage, given that this past year is the first year that they have been successful at raising young, I'm hoping that they're going to start building and that we can keep this up. And the nice thing about this is, as much as you might have looked at those fences and thought, oh, well, there's not that much room inside those fences for those common terns, the fences are not really doing anything other than holding an electric fence that birds will perch on. And once the birds perch on that electric fence and get shocked, they bugger off and they leave the colony alone. And they leave them alone. It probably protects more than one island, even though there are fences on two of the three islands. So it will, I think, be quite effective into the future. We just have to make sure we've got a team of field assistants that are paying attention, making sure that there are no shorts, and that we have something that will give the birds something to think about and give the coyotes something to think about.
Okay.
Um, Now, I'm not sure I answered that question. The numbers of common terns in the lower Great Lakes are much larger than the numbers in Hamilton Harbour, although Hamilton Harbour has hosted quite a large number of common terns relative to the lower Great Lakes. But those numbers are declining in the lower Great Lakes.
Okay. Thank you. So another question from Pat. So if you have to move the nests and there are eggs in the nests, how do you handle this? Are the eggs destroyed?
I don't know that we move nests. I
Okay.
don't think we
Okay.
don't move nests. We the only nests we move are cormorant nests that we're trying to destroy.
That's right. I think that's what she's referring to are the cormorant nests.
Yeah, cormorant nests. We don't we would not move them if they had eggs that hatched. We're hitting them so frequently that there's usually going to be only one egg in a nest. But the cormorants are so persistent that they'll build that nest up again and lay another egg in it, and on it goes from May until June. So
Oh,
I'm reluctant to do that, but we're trying to protect these other birds, and the only way we can do it is by removing their nests. I'm
all
not
right.
sure what we do with their eggs anyway. They're probably not very tasty.
Fair enough. If you could do a very quick fire, or we can answer in the chat later. Um, quickly, do you ban the birds?
Well, not all of the birds. We banded the common tern chicks. We ban birds when we have a reason to ban them. If we're trying to track them, we ban them. In the past, we banded all the herring gulls in our mutation work because we had to keep track of them. We have banded Caspian terns in the past because we want to keep good close track on their population. But the work we're doing right now involves banding only of common tern chicks.
Okay. Okay, that's all the time we have for the Q&A. There are unfortunately a couple of unanswered questions. Hopefully we can get to them in the chat later on in the session. So Jim, maybe we can find the best way for you to answer within the Q&A. I can give you some instructions in the background. But just to kind of whet your appetite a bit, two last questions. How are these species managed on the spit in Toronto? And do you think that avian bird flu has had an impact on the birds in the area? So I can give you some directions in the background so you can answer those later on. Okay. Thank you.
Yep.
Off to you, Caroline.
Fantastic. Thanks so much, Jim. Always learn so much. So next up, we have Shane DeSola. Shane is an ecotoxicologist with Environment and Climate Change Canada, where he conducts research on the effects of contaminants on wildlife and freshwater ecosystems. His work focuses on examining levels and trends of both legacy and emerging pollutants such as PCBs, mercury, and PFAS in the environment. He also studies the effects of contaminants. Sorry, he also studies the effects contaminants have on the physiology, reproduction, and health of wildlife. He manages the Great Lakes Herring Gull Contamination Monitoring Program. Take it away, Shane.
All right, hopefully this works. I have some bad news for you. I have no Santas or anything else like that to show. I can't compete with Jim. Let's see if I can get this to work. All right, how does it look? Can you
Looks
see
good.
okay?
Yep.
All right. Thanks for inviting me. I'll be talking about contaminants in herring gulls in the Hamilton Harbour area with some reference to the rest of the Great Lakes. Let's see if we get some. Ah, there we go. About a little bit of background. Some of the data I'll be talking about is coming from the Great Lakes Herring Gull Contaminant Monitoring Program. This is a program that started way before I was working for Army Canada back in 1974. And the reason why it was started was because at the time there was widespread reproductive failure of cloning waterbirds. So the hatching success was very poor. There's high levels of deformities in many of these chicks, and some populations were actually declining. There were many other factors driving cloning waterbird populations, but it was determined at the time that one of the factors that were suppressing the populations of cloning waterbirds in Great Lakes was things like PCBs and pesticides such as DDT and mercury. And so they started a program to track these contaminants over time to see if A, are they going down, and B, where are the worst sites or better sites so they know where contaminants were a bigger issue. Since about 2008, we've been expanding this program to include other chemicals which are currently or recently used in Canada, such as flame retardants or surfactants such as PFAS. So the compounds which are recently or currently being produced somewhere in the world and maybe showing up in the Great Lakes. So here are our annual monitoring colonies. Ever since COVID, we haven't really gone to the state very much, first because of restrictions in travel and then problems with the change in government recently down in the United States. We haven't really been going to the US side for a while, but we still managed to keep going to the Canadian sites. So we get data from a number of areas from Cornwall all the way up to Thunder Bay, pretty much. And of course, the site in red is, of course, Hamilton. We go to these colonies mostly by boat, occasionally by helicopter, and we collect herring gull eggs. And we use these for contaminants. So for each site, we get about 15 eggs, one egg from each nest. And we also do some other measurements while we're there. And these eggs are brought back to our laboratory to measure contaminants such as PCBs, OC pesticides, mercury, or other things like PFAS or whatnot, which we'll talk a little bit later. And then we can track the contaminants over time, as well as look at which sites are more contaminated or less contaminated. So I'll start off with one of the old bugaboos. PCBs. These are probably the most abundant organic contaminant found in the Great Lakes. They were banned in production in 1977 in North America. However, the use of it continued onwards. In any case, we have here data from basically three sets of colonies. One in blue is Hamilton Harbour, but we also have the one in orange, which is the other two Lake Ontario sites, which is Toronto and Snake being Kingston. And the one in green is basically all the data we have in the Great Lakes, excluding Hamilton Harbour. But these graphs are actually very similar between each other. You can see that there used to be very high levels back in the 1970s and 1980s, but at the same time, they're dropping rapidly. However, once you get to past the 2000s, the rate of decline actually sort of went down quite a bit. So this is just one compound that we were measuring way back when. There's also things like Mirex and DDT, these common pesticides. There's dioxins and furans. I'm just showing you PCBs because A is the most abundant, and B, the trends for most of the compounds were actually very similar to this. So if I had a graph of DDT or whatnot, you see the same sort of thing. The point is that the contamination levels were very high back in the 1970s, 1980s, and they're much lower now. They're only about 5% or maybe up to 10% of what they used to be back in the 70s or 80s, which is a sort of a good news story. There is one thing, though. I'm just focusing here primarily on Hamilton Harbour. The ones in blue, you can see not only is the decline pretty much sort of disappeared, but there's a small, very small, but nonetheless resurgence in PCB levels in late 2019 to about 2023. PCBs in Hamilton Harbour. We see it in a few other sites, but it's more in Hamilton. We suspect this is from resuspension of contaminated sediment, possibly from the remediation that's going on in Hamilton Harbour. Hopefully it goes back down again. But as I said, most of the compounds look like this, where they'd be rapid declines back in the 70s and 80s, and sort of tailing off now in the last few decades. How do gull eggs from Hamilton Harbour compare with the rest of the Great Lakes? So this graph I have here, it's a bar graph that shows concentrations of PCBs and a number of OC pesticides, OC being organic chlorine pesticides. These pesticides are either completely banned or mostly banned. PCBs, as said, have been their protection stopped in 1977, and OCS is octochlorostyrene, and that's a byproduct of chlorine production. The big story here is that Hamilton Harbour is among the more contaminated sites, but it's certainly not the worst at the moment. The worst sites are actually Channel Shelter and Big Sister, which are on the U.S. side of things, either Lake Huron or Lake Michigan. There's a lot of industry nearby some of these sites, or Channel Shelter was also a place where they actually dump contaminated sediment, which is one reason why they're so high. Having said that, in the Canadian side of things, Hamilton is, not the worst, but not all that great. Toronto is slightly worse than in Hamilton, and the other site in Lake Ontario is Kingston. You can see it way over there on the left-hand side, where it's really no different than some of these sites up in Lake Superior or Lake Huron, which is much cleaner. So you can certainly see a large difference in the relative contamination in colonies across the Great Lakes, depending upon where they are. Now, here's a new group of compounds. They're not really new, but they haven't really hit people's attention until about 15 years ago. These are PFAS. The particular type of PFAS I'm talking about here is ones called PFSAs, or perfluorosulfonic acids, but there's many other ones like carboxylic acids and so on and so forth. But these are the ones which tend to be the most abundant in biota, like basically in animal tissue. The problem with PFAS is that many of them, such as PFSAs, are very bioaccumulative, and they're also, sometimes they're called forever chemicals. They're very persistent. They tend not to break down very much, so they tend to accumulate very well. So I'm not showing a trend line here, but I'm showing all the colonies from Lake Superior all the way down to Cornwall, and also included Montreal, which is the Ile des Lauriers. So basically, going from left to right is from upstream to going downstream. So way upstream is granite and agua rocks, which are Lake Superior. They're fairly low. You can see as you go further downstream, the concentrations are a little bit higher until you hit Hamilton, and Toronto. And then these two sites have the highest concentrations you'll see in the Great Lakes. So it drops down a bit, going to Cornwall and Kingston. It goes up a little bit once you go downstream of Montreal. These are also highest concentrations you'll see in gull lakes, anywhere from the East Coast all the way to the West Coast and up north. Now, if I try to show you all the graphs for each one of these compounds, we'll be here for a very long time because we measure OC pesticides, dioxins and furans, there's mercury, we have metals like lead, things like that, PCBs, and so on and so forth. So what I try to do to simplify the reporting of all the contaminants is coming up with a Wildlife Environmental Quality Index, or I call it WECI, the WECI index. And this index tries to combine multiple contaminants into a single score to indicate not absolute exposure, but relative exposure for wildlife. So far, I've done it for PCBs, dioxins, furans, and OC pesticides, and I do plan to expand it to other sort of compounds. But what it does is it takes all these compounds that we measure simultaneously and use it in the same in one index. But we also include hazard data. That is, we actually include information from guidelines. So any exceedances of guidelines to protect fish-eating animals. And we get this index in which the values go from 0 to 100, where 100 is really good, everything's perfectly clean, and 0 is terrible. So what we want is to get the numbers as high as we can. I'm showing here a bunch of different graphs from Lake Superior, Lake Michigan, so on and so forth. Each one of the Great Lakes, these are represent different colonies. I'm not going to be talking about that very much, but I'm going to simplify it by showing just Lake Ontario. So here is a WECI trends, that's the Wildlife Environmental Quality Index for Hamilton, Toronto, and Kingston. So Kingston is the one in green. As you can see, it's going up slightly. So there's a small improvement from 2012 to 2023. So that's a good news story. Hamilton and Toronto actually got a little bit worse over the same time frame because the numbers are actually going down. And this is driven largely by PCBs. And the reason why it's going down is because there's a small, very small, but nonetheless, resurgence of PCBs, at least in Hamilton, and so it's starting to drive down the index. Now, it looks pretty awful looking at this graph, but keep in mind that the y-axis goes from about 25 up to 50. If you actually had this in the full axis from 0 to 100, the differences be much smaller than what appears here. So while there are some changes in the environmental quality index, they're actually a very small magnitude. Now, if I did this graph going back to 1974, it would look very differently. The WECI has been improving dramatically over the time frame as the contamination, particularly PCBs, have been dropping. But within a shorter time frame, you can see that, well, it's not always getting better. Sometimes it may be getting slightly worse. Nonetheless, the environmental quality index indicates much better quality now than it has been back in the 70s, 80s, 90s, or even the early 2000s. Now, we've also been doing some work looking at the health of colony waterbirds in the AOC. This is not really my work. It's one of the authors I put in the front of my talk, Doug Crump and Kim Williams, neither of which I believe are here online. Otherwise, I make them give this talk. And they did this field and lab study to assess the health of colony waterbirds, particularly herring gulls, within the Hamilton Harbour AOCs, one of the BOIs for the deformities and reproduction problem BOI. And so they're examining reproduction and development of herring gulls within the AOC and comparing them with gulls that were nesting in a suitable reference site, which I'll show you in a bit. So they were actually looking at pretty high levels of health or measures of health. So they weren't looking at gene expression or anything else like that. They were looking at survivorship, deformities, productivity, number of chicks per nest. They did do some work in the thyroid hormones and a couple other assays like that. So they had two approaches to looking at the health of birds. On the left is Doug Crump, crouched over grabbing an egg, and on the left of him is Kim Williams. They collected unincubated eggs for artificial incubation in the lab. So they got fresh eggs out in the field. They brought them to NWRC, the National Wildlife Research in Ottawa, and they put them in incubators and they brought them to hatching, and then they assessed the health of the chicks at the hatching. And the second thing they did is that they built enclosures around the gull nest in Hamilton to assess productivity and health of the chicks that are in it. You can see one of the enclosures being built on the right. So here's, I believe this is Near Island. Far Island has already been obliterated by this point. So they put these enclosures around nests which are already there. And the gulls don't seem to mind them. They will keep on nesting and bringing up the chicks. And it prevents their young from wandering around all over the place. So we know which chicks go with which nest. Then later on in the year, they go back to these nests and they look at the health of the chicks. They count how many of them there are. So that gives an idea of productivity, how many fledgling chicks are per enclosure. They look for deformities. They do band them, do body measurements, and they have various physiological measures of bird health. Here's the location. So Near Island and Pier 27 were the two sites within Hamilton, and the reference sites were pretty far away. They're basically Presqu'île and near Kingston. Salmon, Snake Island, and Scotch Bonnet Islands were the reference sites they used to compare the health of birds with the ones within Hamilton Harbour AOC. Here's some data. I'm only showing a little bit here and there. They have other data, but I'm just showing sort of the big ones in terms of measures which affect population levels. So these tables show embryonic viability, basically hatching success, and deformities. And the big story is that they pretty much all hatched. So all the eggs are brought to the lab. They all hatched but one, and the one that didn't hatch was from Salmon Island, which is a reference site. And also they had very few deformities. Again, one from basically Salmon Island. So the hatch success was very good. Deformities was very low. And the bottom table shows the deformities of wild chicks. And you can see that, they're all were 0, which is, good. The productivity, we have estimates. I didn't put it in the slide, but productivity is actually fairly high at all these sites. It's actually higher than what you require to maintain a stable population of herring gulls. So there appears to be no impairment. Using the other measures that they're looking at, such as immune function and thyroid hormones, there really wasn't any difference between any of the nests between Hamilton Harbour and the AOCs. This graph, I probably should make a slightly better one to be easier to understand. So we've got 3 checkered sort of lines going across. These are thresholds, sort of like the mean threshold and the maximum threshold are found and the lowest threshold for levels of PCBs and eggs associated with suppressed reproduction in birds. So between 8 to 20 micrograms per gram. And at the very bottom, you can see all these dots with the blue lines. These are the means and the 95% confidence intervals and 95% predictive intervals. That doesn't matter a whole lot. What you want is to have all these values below the thresholds. You can see Hamilton Harbour in the very far right. They're all below the lowest threshold. There's a couple of sites which start to peak up above it a little bit, Middle Island and tiny bit of Toronto. But the point is that the levels of PCBs appear to be low enough that we should not expect to see suppressed reproduction in these birds. It's a little bit closer than I would like, but it is sort of below. And looking at thresholds for other compounds such as DDE or mercury, they're that much further below the thresholds for toxicity. Looking at the levels of contaminants in the eggs, we don't really expect to see any effects on the reproduction of these birds. And as I showed beforehand, there wasn't any differences in measures of health that were used between Hamilton Harbour birds versus the reference site. So overall, we sort of made the assessment that there really wasn't any really obvious population level effects of contaminants on these birds. Not to say that there can't be sublethal effects, but there certainly shouldn't be driving down populations like they used to back in the 1970s. So overall, the legacy contaminants such as PCBs and DDT, these compounds which were banned have declined substantially, but they kind of flatlined over the last decade. They're not really going down. PCBs still are the dominant organic contaminant in these gall eggs, despite these newer compounds that have been released in the environment, such as PFAS or flame retardants. So these newer compounds, which haven't really shown here very much, some have increased, but most are sort of stable or decreasing. But They're always making new compounds, so we're still looking out for other ones. And based upon the current available data, we have no evidence of contaminant-induced impairment of reproduction of herring gulls within the Hamilton Harbour AOC. That doesn't mean that there aren't other things driving down populations, as you've seen from Jim's talk, but there's no really strong evidence suggesting that contaminants are things driving down the populations. And that is it. Thank you very much for listening. And if we still have time, I'll take any questions.
Thanks so much, Shane. Great talk. That's definitely a topic I don't know much about, so I learned a lot. Thank you for sharing your knowledge there. We do have about 5 minutes for questions, so I'll pass it over to Mike.
That's great. Thanks, Carolyn. Yeah, we just have one question coming in now. It's from Quinn. What do you think the main sources of PFSAs or PFAS compounds in Hamilton Harbour are?
I would say that there aren't any sort of main source of PFAS or multiple possible sources of PFAS. Was used in so many different types of products. There are industrial sources, municipal sources, and it's long distance transport as well. So one of the main sources of PFAS in the general area, which is not really Hamilton Harbor, but there may be some runoffs from this, is actually at the Hamilton Airport, where there's a lot of PFAS that was released from HHRAP, which is aqueous film-forming foam. It's used to put out fires. But there are wastewater treatment plants in Hamilton, and that's an important source of PFAS coming in. There's a number of industries that used to use PFAS in the production, such as metal coating, which can also be a source of PFAS. And so there's not any one source, unfortunately. There's a number of different sources all sort of piling in this one area. It's a lot of industry, a lot of people in the Hamilton area. So there's probably a number of different possible sources that are coming in.
Thank you. Next up from Deborah. Do zebra mussels filter contaminants from the water? And if they do, are the contaminants concentrated in their bodies, resulting in substantial danger for birds that consume them?
Yes, they certainly do filter contaminants from the water, but also not just from the water, but also in the particulates that are actually in the water. So they filter out bacteria and algae and that sort of thing. So it's not just the water, but there's also contaminants in the plankton, the phytoplankton that's actually growing in the water as well, and they filter out sort of both of them. So they do accumulate contaminants that way. On the other hand, they're also fairly low on the trophic levels. So that for substances which are bioaccumulative, the higher the trophic level you are, the higher the concentrations that you tend to get. So if you look at, for example, algae, they're fairly low in terms of PCBs, as just one example. But then the zooplankton, which eat the phytoplankton, will have slightly higher concentrations. Then the small fish that eat those will have even higher. Larger fish will eat them will have even higher concentrations, and then gulls or cormorants will have the highest concentrations of those compounds. Now, zebra mussels are important for transferring contaminants, not only by picking up from the water and from the plankton that they're consuming, but also they change the dynamics of how the sort of energy flows through the system. So productivity used to be really high in open waters in the Great Lakes and also in the harbor, but particularly in the Great Lakes. But zebra mussels, because they live in the shallow areas, they've been drawing much of productivity away from the open water into the shallow areas. There's something called the nearshore shunt, and that increases the amount of productivity in the shallow areas. But it has interesting consequences for contamination of our fish-eating birds. Gulls don't eat that many zebra mussels. They're usually too far down. Some fish do eat them, such as gobies, but gobies are benthic fish. Gulls can't dive deep in the water to get fish. They can only feed what's on the edge of the water or on the surface of the water. So they eat things like smelt or alewife or anything washed up along the shorelines. Double-crested cormorants, however, they can dive a long way down, and they eat lots of gobies. For people who hate double-crested cormorants because they're not native in this area or whatnot, they eat copious amounts of gobies, which are invasive. So they're eating these birds, which actually are native, are actually eating invasive species. One thing to keep in mind. But zebra mussels do change how the contaminants are removed, because now they're sort of cutting off the herring gulls because they can't eat the fish that eat the zebra mussel, but cormorants can. So zebra mussels will have different effects depending on what type of fish-eating bird you're actually talking about.
Very cool. Very cool. That was great. And that does it for questions. So with that, I'll pass it back to Carolyn. Thanks very much, Shane.
Okay,
Okay,
thanks
thank
so
you.
much. Okay, just a second here. Okay, thanks everyone. Thank you as well to Mike for facilitating that Q&A session. That's super helpful. And we get a nice different perspective as well. So thank you to everyone for joining us for our deep dive webinar series. You can continue to learn more about the Hamilton Harbour Remedial Action Plan through our social media and website. Remember to sign up for that mailing list to be directly informed of future webinars and other engagement events. A recording of today's session will be posted within a week, so you can share that with someone if you think they might be interested. We hope to deep dive with you again in the future, and we're planning to host another session around the autumn this year. So I do have two final polls. We'll do them a little bit differently. I will launch them at the same time, read them out, and then you have as much time as you want with them to fill them out. They are just a bit of a longer answer if you'd like. And after that, we'll be all wrapped up. So thank you again, everyone, for joining us. And thank you so much to our presenters, Jim and Shane, for your fantastic presentations today. So let me just launch those two polls. So at the end of this session, we just want to know from you, what was something that you learned that you didn't know before about waterbirds in Hamilton Harbour? And lastly, what excites you most about Hamilton Harbour? We just want to hear how this kind of a presentation impacts your perceptions and what you're taking away from this. So please take your time to answer as you will, and we hope to see you at another session in the future. Thanks so much, everyone.
Thanks, everyone.